Hello everyone, this is your Bhavadharani. In this video, I'm going to talk about the topic structure pattern, which comes under the subject software architecture and design pattern. Introduction. Structure pattern is software Structure pattern is a software design which focuses on how objects and classes are composed to form larger structures while maintaining flexibility and simplicity. These patterns are essential because they help organize and structure the code in a way that promotes reusability, scalability, and maintainability. By using structural patterns, developers can solve common problems related to object composition, class organization, and managing the relationships between various components in a system. This pattern aims to reduce complexity, increase modularity, and ensures that the system remains adaptable to future changes without significant refactoring. So let's discuss about the types of structure pattern. There are several types of structural pattern, each designed to address a specific problem related to how objects or classes are structured in software. The most common structure pattern include adaptive pattern, bridge pattern, composite pattern, decorator pattern, facade pattern, and flyweight pattern. Enables incompatible interface to work together, decouples abstraction from its implementation to allow both to evolve independently, treats individual objects and composites of objects uniformly, typically used in hierarchical structures, adds behavior or responsibility to an object dynamically, simplifies a complex system by providing a unified interface, reduces memory usage by sharing common object data across multiple instances. Adapter pattern is used when there is a need to make two incompatible interfaces work together. It acts as a bridge between two different interfaces by converting one interfaces into another than a client expects. This pattern is useful when integrating legacy system with new components or library. The adapter does not modify the existing code but instead create a layer that allows the systems to communicate without any direct changes to their interfaces. This pattern promotes code reusability by allowing new systems to interact with old ones without having to rewrite existing code. A common example of this pattern is a plug adapter that allows a European plug to be used in an American sortant where the interference between the two is incompatible. Bridge pattern. The bridge pattern is designed to decouple with an abstraction from its implementation, allowing the both to evolve independently. It is particularly useful when both the abstraction and the implementation are likely to change frequently. The pattern involves creating an interference and a separate class that implements this interference, which allows you to vary the abstraction and implementation independently. The bridge pattern is commonly used in scenarios where the systems need to support different platforms or environment with varying implementation, but the higher level interface remain constant. For instance, a remote control can work with various devices such as TVs, radios using the same interface but different implementation for each device type. Composite type allows the clients to treat individual objects and a composition of objects uniformly. It is particularly used when dealing with the tree-like structures or hierarchical data. With this pattern, objects are either leaves or composites and both are treated in the same way by the client. The pattern simplifies the design of systems that requires composite structures such as file system or organization charts. By treating individual objects and their composite groups the pattern allows the client to interact with the system in a simpler, unified manner. A classic example of a composite pattern is a graphics application where both simple shapes and complex shapes are treated uniformly. Decorator pattern. The decorator patterns allows you to dynamically add behavior or responsibility to an object without altering its core structure. This pattern is particularly useful when you need to extend the functionality of an object at runtime. Instead of creating new subclasses for every possible combination of features, the decorator patterns allows you to create individual decorator that can be applied to an object as needed. This avoids a subclass exposure and keeps the system flexible. For example, in a coffee shop, a solution or application, a basic coffee object can be decorated with the additional features like milk, sugar, or whipped cream added to a separate decorator without modifying the original copy. Facade pattern. Facade pattern Facet pattern provides a simplified, unified interface to a complex subsystem, hiding the internal complexities of the system. It essentially acts a front-facing interface that simplifies interaction with a complex set of operation or classes. By using the Facet pattern, developers can reduce the number of interactions a client needs to make with the system, make it easier to use and understand. The flyweight pattern is used to reduce the number of objects created and to decrease memory usage by sharing common object data among the multiple objects. Instead of creating a new object each time, the flyweight pattern allows objects to share their behavior while maintaining the separate intrinsic status that can be vary objects. Comparison of structure patterns resolves interface incompatibility by creating an intermediary that converts one interface to another. It is adaptive. Bridge decomposes abstraction and implementation, allowing both to evolve independently. Treats individual objects and composition of objects uniformly useful for tree-like structures. Composite decorated dynamically add functionality to object at runtime. Facet simplifies complex subsystem by providing a unified interface to clients, minimize memory usage by sharing common object data across many instances. Conclusion. In conclusion, structure pattern plays a crucial role in organizing classes and objects in a software system. This pattern helps simplify complex design, promote reusability, and improve maintainability by managing the relationship between the objects and ensuring that the system remains flexible and scalable. By understanding and applying the appropriate structure pattern, developers can create a software system that are easier to modify, extend, and understand, whether through decoupling, subtraction, simplifying interfaces, or reducing memory usage. These patterns provides a valuable solutions for many common design challenges in software development. This was all about the structure pattern in software architecture and design pattern. If you like my video, please do like and comment. Thank you.